example I can teach you. Getting here? So all in combination we have to start. So now as you can see, so we are using what our AI project life cycle. Okay. So usually how your any AI project, okay, usually all your projects now you are going to do inside the AI, right? So how does your AI project life cycle will be going? So usually what you will be having a problem scope will be there. Okay, data acquisition is there, data exploration is there, modeling is there, evaluation is there, and deployment is there. These are the different phases in your AI project life cycle. So any AI project is based on this. So it has to undergo all these 6 phases. Okay. So one by one, we'll see what you mean by this. Okay. So problem scoping. Problem scoping means what? Whenever you want to solve anything, your picture is given or a scenario is being given to you, and you want to solve that particular problem. Okay. And you have to clear the solution. Okay. So that is mean by problem scoping. Now, what do you mean by data acquisition? Now, for solving that particular problem, you have to the data sources, right? You have to get your data sets. You have to get different data sources from different sources, authentic sources. You have to get it, right? So all those collection of data is nothing but the data acquisition, which is done from different data sources. Next is what? Exploration. Okay, what do you mean by exploration? After collecting the data sources, you have to draw, you have to explore, you have to create the insights, right? So for creating the insights, you have to make your visual image. So how do you make a visual image? By creating a graph, by creating a map, or if using a word and all, you will draw a flow chart, right? So if you're using databases, you are creating ER diagrams, right? So these are some of the different types of representations. Okay. So how do you explore your project life cycle? By any of these. Either you will create a ER diagram for, as if it is a database, you will draw a flow chart, you will draw a map, you will draw different graphs, charts. Already you have done, right? Charts and graphs. So you can use any of those. Next is what? Modeling. So after exploring everything, after creating the charts, now what you will do, you will create various types of models. Why you are creating the models? You are creating the models. Why? Because you want that particular model to give the exact output. Whatever output you want, the same output it has to represent. Okay, so the model is nothing but it is following a particular pattern. Okay, whatever you are telling, that pattern it will follow and it will give you the desired output. Okay, so once you have done with your insights, you will create the models, different models you will create and keep however you want. So those models are nothing but by they will use machine learning algorithms. So usually all machine learning algorithms, what they are doing, they are following a specific pattern. Okay, if that pattern is matching, the output desired output we will be getting. Okay, so next is what? You are going to test the selected models. Okay, after you have created 5 models by using 5 machine learning algorithms are there, you will create 5 models. Okay, up till charts you have finished. Okay, you use Matplotlib programs, you use Seaborn programs, you created graphs and charts. Now you have to create the models. For creating the models means what? You are creating different types of patterns. What you are going to use? You are going to use different types of machine learning algorithms. Each algorithm is having a specific feature. Okay, now once you know that 5 algorithms and you have created a 5 models, 5 models, all 5 models can you use? No, right? You will use what? The best. Okay, so if you want to know which is the most efficient model, if you want to know which is the best model, then what you have to do? Out of 5, you have to test one of the model as an efficient model. Whichever is comes as an optimized or efficient model, that model you will select and you will put it as an final output. Okay, so once you are testing your model, then the result will help you. Whatever result you will be getting, it will give whatever the result you will be getting, you are going to evaluate it. Suppose in 5 models, there are 5 different algorithms, and in all 5 algorithms, you are having what? Different models you created. So each one is having a different feature. Each algorithm is having a different feature over here. But which is the best suited for you? Getting here. So which model is the best suited for you? That only you will take, right? And finally, after the evaluation, you get the deployment stage. What do you mean by deployment? That means what? In real world environment, you are going to successfully integrate your model. How does it work with your clients? Your model, what you have created, that should work well with the clients. It should suit with your client requirements. So you will put your all AI models, whatever you have done by using ML and AI, all those models, it has to be integrate with your real world environments. Okay, then only whatever you have done is correct. Are you getting? This is a simple AI project life cycle. Hello.
Yes, ma'am.
Right. So this is any project you do. Now you will do any AI and ML project, right? So all the projects should undergo these phases. Okay, so step by step you have to undergo all these phases. Okay, now AI models are basically categorized into three domains. Okay, one is the statistical data, second is your computer vision, and the third one is your natural language processing. These are the three domains where the AI models are categorized. Okay, so now what do you mean by statistical data? So the quantitative information collected and analyzed. So what do you mean by quantitative and qualitative? I have taken right this part.
Yes, ma'am.
Yeah, so what do you mean by quantitative data?
Quantitative
Huh?
is a numerical data.
Yes.
It is a measurable one, whereas
Huh.
qualitative is a descriptive or categorical type of data. It's not a basically it is not a numerical data. That comes under qualitative.
Yes. So quantitative can be expressed with the numerical values. So suppose, for example, I say age, right? It's age or my salary, right? So what are these? My sales. What are these? These are all numerical values. Yes or no? So all these come under what? Quantitative data. So all these, see here, statistical data that comes under the numerical in nature. And if numerical means you can do mathematical operations, right? So those data which we can undergo the mathematical operations are called as what? Statistical quantitative data. Okay, so usually whenever you are using any numerical data, whenever you are using any quantitative data, you have to they what they are giving you output what they are giving you, these data, quantitative data, what they are giving, these are giving you these are helping you for understanding the patterns. Some patterns they are giving, some trends, some relationships they are giving you, they are showing you some of the best relationships within your data set. All these they are giving. Okay, and always remember these quantitative data, very important point. This quantitative data or this quantitative statistical data is always used in machine learning models. For what purpose it is used? For making predictions, for decision makings. Okay, so whenever you want to train your machine learning, you will be getting two types: training, trained, and the tested. Okay, what do you mean by that? That we will see later. So whenever you are going to make your machine learning models, okay, whenever you will train your machine learning models, at that time, always you are using what? Statistical data. Okay, so this is quantitative statistical data you have seen. Okay, so this is one type of the statistics data. Then structured data. What do you mean by structured data? Structured data is nothing but whenever you are having any data in terms of tables, okay, or in any particular structure format. Okay, so all your rows and columns data. So all your tables, whatever you are creating in your SQL, right? Whatever you are having in your CSV files. Now CSV files can you call it as an structured form? Hello? Excel file is there. Excel files you are having rows and columns. Yes or no?
Yes, ma'am.
Data frame you are creating. Is it having rows and columns? Yes. Yes
Yes,
or
ma'am.
no?
Yes, ma'am.
But CSV file is there. Do you have a rows and columns in CSV files? How is the data is there in CSV files? All in the delimiters.
Yes,
Okay.
ma'am.
So it is not in the tabular format CSV files. So all these structured tabular format data are there. That also comes under the statistical. Okay. Then you are having large scale. So large scale means what? Very large data sets. Simple. Okay. And variable. Variable means what? All the categorical data. Okay, so we have seen, right, all the categorical data means what? All the labeled data. Okay, apart from numerical and ordinal variables, you can use your categorical data also. Suppose gender is there, male and female, right? So it is not numerical. So categorical data. So all these can be considered as what? Statistical data. Okay, so these are some of the examples of statistical data. See here, sensor readings, right? IoT devices, you know, right? Internet of Things devices. So sensors, there are different types of sensors: temperature sensor, motion sensor, pressure sensor. In smartphones, you are having sensors, right? So smartphone is working under the sensors. So all these sensor readings, this is an very best example of statistical. Then customer transactions. So in bankings, you are having the customer transactions. So you are having the bank statements, right? So all these come under what? Statistical data. Same thing, medical records in your medical field, patient health data, medical histories. Okay, all are also termed as what? Statistics. So same thing, you are having image and video data. Okay, then you are having price comparison websites. Means what? Suppose you are having many. You are having a startup company, right? You are having many vendors. Okay, so what will you do? So if you want to see, okay, the product of a particular price, how you purchase from a vendor, what is the technique that you are following? General technique. So there are 5 vendors. What you will do if you want to purchase any product, if you want to purchase a set, so you will compare the prices of each vendor. Yes or no?
Yes, ma'am.
Right? So you will go and see their websites. You will see the price, how much is there. So I want the books for suppose 100 copies. So what will be the print? I'll check the print, right? So per copy, how much is the print coming? So which is the best suits to my thing? That vendor only I'll go and approach, right? So you are going to compare as per your convenience. Okay. So in AI, so these were all what? The related to statistics data. So second part in AI, as we told, is what? Computer vision. Okay, second thing. So computer vision means what? Whenever you want to it is a field. Okay, computer vision is a particular field, like data science is there. Like that, it is a field where you are going to study the computer the images and videos. Okay, whatever images and videos are there related to your data sets, so that you are going to study. Okay, so how do you study those images and videos? You are going to create a different visuals. Okay, you will create a different insights, and then you can come back to a particular solution. So this computer vision is having what? Image acquiring, screening, extract information. All these are some of the methods. Okay, so how do you do that? You are going to input the machine. Okay, the machine, you will put some photos, some videos, some pictures you are going to put. Okay, and what you will use? You will use the sensors. Which are the sensors that you are using? Infrared sensors. Okay, and you will get your desired visual, desired output you will be getting. This is the way that how the computer vision works. Okay, so usually what these are nothing but computer vision are nothing but the training machines. These are trained. That means what? For the first set, one example, you will train that machine. So for second and third attempt, by using the first thing, it will automatically generate the output. Okay, so training machine means what? The human is going to train the machine. For the very first instance, we are training the machine. So according to our training given, according to our trained data is there, right? It is stored in the machine. Our trained data is stored in the machine. So it will check our trained data, and the next, second, third, fourth, right? Whatever you are asking questions, it will give the results according to your trained data that is being fed. So it is putting you what? It is mimicking the human visual system. Okay, so these are all the various tasks that the computer vision is doing: object detection, image classification, right? Image segmentation, image generation, image to image translation, video analysis, video content creation, right? All these tasks are done by the computer vision under the AI. Getting it?
Yes, ma'am.
I've heard, right? All these. Yes or no?
Yes, ma'am.
Right? So now, so the applications you all know, right? Self-driving cars, Tesla, right? So this is also being done by using the AI and computer vision, facial recognition, medical imaging, robotics, right? CCTV surveillance, agricultural monitoring. All these are some of the applications which are worldwide used under the AI, which uses the computer vision. Okay. And the third one is what? Natural language processing. In AI, the third common type is what? Natural language processing, NLP. So this is also a field of computer science where you are going to generate your natural language data. Okay, so the human language is there, right? So you are using, suppose, English, or you are using Hindi or Telugu or Kannada or Tamil, whatever you are using, any language, you can just interpret it. Okay, you can analyze, you can generate your own language by using that particular language. Any language you can give in NLP, so it will come back with you with the output. Okay, so in NLP also you are having different tasks. Okay, so text classification. What do you mean by text classification? So categorizing the text into predefined categories means what? Now in your Gmail you are having, right? Inbox you are having, post mail, inbox, important, spam, trash. What are these? They have categorized your email box into different categories. Okay. So you are having important comes under all important things in inbox, and spam goes under emails. How does it do? How does directly all the spam mails go under spam? Why? Because of the NLP. Okay, so because of this natural language processing processor, all your spam mails go under your spam emails. Same thing, you are having sentiment analysis. So you are having the emotions, right? So you are giving some of the emotions, that emojis you are giving, right? Have you done with in your feedbacks? Are you using the sentiment analysis? Whether you are happy with this, how much do you rate this? Yes or no?
Yeah, for giving the feedbacks.
Huh, have you used this? Are you happy with this? So they are giving you emojis, right? The smiley face they will give.
Yes,
right?
ma'am.
Huh. So what is this? So these are all sentiment analysis. So a very big smile means positive. A very dull smile means it is negative, right? So you can do this by using this NLP. Same thing, named entity recognition. So you can identify your entities. Entities means what? Attributes. Okay. So it is simple, which is done in any of the data sets. Next is your parts of speech. Okay. So you can identify your grammatical category. Now in MS Word, you are having the spelling and grammar check, right? How does it comes? By using NLP. Are you getting?
Yes, ma'am.
Same thing, you are having speech to text, text to speech, right? So the Google is helping you by according to the voice recognition, right? So that also uses your NLP. Okay. So all this, whatever was there, where it was. Yes. So image to image translation, video analysis, right? Video content tracking. So all these are using NLPs only. Okay, so now whenever you are using NLP language, the main useful thing in NLP is what? Nowadays the trend is what? Building the chatbots. Okay, so many chatbots, those are built by using your NLP language. So here what you are doing, you know, whether you it is an AI based NLP or whether it is an machine learning algorithms, you are going to use the code. You are not directly writing the code. Everything you can't remember. So up till now, Matplotlib, Seaborn coding is fine. You can remember those. But these all codings, these all header files, you can't remember. So what you will do, you will search it. Okay, there are so many tools. Okay, for chatbots, for sentiment analysis, everything is being given. I'll show you those tools. Okay, so from those tools, you can collect the information and you can copy the code. Okay, so that is what you are going to learn, how to build the chatbots. Okay, so now same thing, mail filters is over, machine translation, yes, it is over. Yeah, this is also very important, tokenization. Now NLP, it will always may use the process of tokenization. Means what? Suppose you are giving one sentence. Okay, I am learning Python programming language. So what is this? This is under what? This is under English language, right? Now, if you want to convert it into your Tamil language, so how does it convert? Right? The NLP has to convert it, right? So what are the phases that it is using? So first, what it will do, it will break down your text into different words or tokens, which is the process called as what? Tokenization. Okay, after breaking down, each and every token will be converted. Okay, each and every token will be converted with a particular method. Okay, that we will see how it is going to do by a particular methods. There are different methods which it is using. So by those methods, it will convert each and every tokens. Okay, so this is the first step in NLP. Okay, in NLP technique, tokenization is the first step. Second is lemmatization, means what? It will reduce the words. Unwanted words will be reduced. Then third step will be what? It will be identify the named text. Means what? Suppose I am giving, I am learning Python programming language. So in this, the main entity is what? Python programming language, right? So it will not reduce that. Okay, so the main entities will not be reduced. And the last technique is what? Deep learning. So deep learning means what? Neural networks. Okay, always remember, deep learning means what? Neural networks. So neural networks means what? ANN, CNN, everything will come. Okay, so all this, next it will use the deep learning. So in detail, we will see how does it work, right? Okay, so this is an activity which you can just go through it. It is not required. Understood up till now? Hello?
Yes, ma'am. Yes, ma'am.
Okay. Now, what is the difference between AI, ML, and DL? We have already seen, right? So AI machine works on algorithms, you know, right? And data fit, and it gives the desired results. AI is usually mimicking the humans. Okay. And what is ML? ML is nothing but it from the past experience or from the past data sets, it is going to give you the outputs. Okay, so in machine learning, usually what you are having what? Test data and trained data, having two things. Okay, that it will use. And next is what? Deep learning. Okay, so deep learnings are what? These are also nothing but these are also uses the trained data. But what is the difference between deep learning and machine learning? Deep learning will train itself. Okay, it is using the trained data and it will train itself. If it wants to perform any task, then it will train itself. Okay, so that is what the difference between these two. So usually in deep learning, okay, you are having a very huge amount of data set. Okay, at that time you are going to use the deep learning. Okay, so deep learning always works with the machine learning algorithms. Okay, do remember, always it works with the machine level learning algorithms. See here, this is your AI, this is your machine, this is your deep learning, right? This, I think so, I have given this file. Yes or no? Hello.
Yes, ma'am, you have
This
shared
particular,
in the
yeah, this
introduction section.
class, yeah, is the first class
Introduction
we
class.
did this.
Yes.
Yes. So
Yes, ma'am.
now, now what do you mean by machine learning? As we have seen from the past experience, this is your machine learning models taking the input and drawing the output. So in these models, what is the input here? What type of input will be there? The past data or the historical data. Okay, so just remember one thing. Input for the machine learning algorithms is what? Past or the historical data will be the inputs. Okay, and the output will be what? Output, it will be generating by whatever inputs you are giving, that is the same output. So now examples of machine learning we will see. Okay, so the very first example is what? Object classification. So if suppose I want to identify, okay, or I want to label any objects present in this image, right? So how many objects are there in this image? See here, three apples are there, three strawberries are there, right? This is my input. Okay, inside the machine learning model, if I give, okay, then the output should come what? It is coming as what? Apple only, right? How does it coming? How is it is coming as an apple? Why not it is coming as a strawberry? Yes, why? Because in machine learning, already I have given that this is an apple. Okay, this picture I have given, apple picture I have given. So it is giving me only apple picture. Getting here. So the output predicted is what? Only apple. Because in your machine learning models, according to the historical data, I have given only the apple picture. I have not given the strawberry picture. Getting here. So it is giving me only the apple picture. Okay. Now suppose I am having here, these are my all inputs, right? These are all my input data. This is your machine learning model. So what will be the shirts categories? All t-shirts and all shirts will be under this. All the bottoms and pants will be under this. All the accessories will come under this. So how does this work by using machine learning algorithms? Because I have given in machine learning algorithm that this is the shirt. Okay, this is called as a pant. These are called as watches. So by using those historical data, it is predicting the output. Okay, simple example. Are you getting? Hello?
Yes,
How
ma'am.
is it working? The theory concept. Okay. Now, what is an anomaly detection? Anomaly detection is also an example of machine learning. So whenever you want to track your heart rate, okay, or you want to see any sudden spike, okay, so at that time, it comes under, it is called as what? Examples of anomaly detection. So usually it is used to find the unexpected results or any hidden things are there. Okay. In your data set, if any hidden things or any hidden items are there. So at that time, you will use this anomaly detection of machine learning algorithm. Okay. Now, coming back, so you know this, right? Machine learning, we have seen this. So all this, you know, right? It has many applications, image recognition, NLP. Yeah, classification, clustering, and regression. These are very important things. You are going to use this in your projects. So in machine learning, you are having classification, clustering, and regression. Okay, these three things. What do you mean by classification? We just seen spam detection, sentiment analysis, image classification. These are the examples of classification. What is the example of clustering? Anomaly detection, customer segmentation. Okay, and what is the example of regression? Predicting the continuous outcomes. Okay, so these are all projects. Okay, any project you can do under this. When it comes to the project part, you have to do the projects. Okay, any project you can do under this. When it comes to the project part, you have to do the project within this only because means AI based chatbots also is fine. Okay, but because these are the latest trends that they are asking inside the companies. Now, these are several types of machine learning algorithms: supervised, unsupervised, and reinforced. Now, what do you mean by supervised learning? Whenever you are having a data set, okay, and that particular data set is having a labeled data. So we'll see what do you mean by labeled data. I'll show you. In this, it is not there, I think. So wait. Again, deep learning is coming. Huh? First, let me see. Let me show you what do you mean by labeled data. Okay. You can open that file, right? Machine learning description I have given. It is there in that. I have given machine learning description file, right?
Yes, ma'am.
Did you get?
Yes, ma'am.
Ha, see, in that you are having types of machine learning algorithms, right? So you are having what? Supervised.
Yes, ma'am.
Okay. So, whenever you are using a data set, okay, and you are having the labeled data, means what? Categorical data. Okay. So, for example, in your data sets, okay, suppose you are having in your data sets, you are having two images, okay, of animals, whether it is a dog or a cat, right? So, each image will be labeled as what? One will be cat, one will be dog, one will be cat, one will be dog, right? Yes or no? So cat will be considered as a cat, dog will be considered as a dog, right? So what is this now? This is called as what? Labeled data. Okay. So here you giving the exact name, label name, target value you are giving, exact name it is. Yes or no? Okay.
Yes,
So
ma'am.
exact name. You can't give a cat as an mammal, right? You can't give like that. So this is cat means what? It is an animal only, and you should give the name as what? Cat. So this is a labeled. Okay. So you can't give anything other than that. Okay. But suppose, for example, if you go with your, I'll just share the screen. Yes. But suppose if you go with your one second, let me see all slides. Yes, here. Yeah. See here. See now this image. So this is for cat. These are the labeled, right? Yes or no?
Yes, ma'am.
So these are called as what? Categorical data, the labeled data. Okay. Now see this. This is digit recognition. Now these are some of the digits. Okay. So how does the deep learning or the AI recognizes these? Right? These are all identifying the handwritten digits, all from 0 to 9 it is. So how does it recognize? See, this is a 9, so it has to recognize from this. Getting it? So always deep learning uses neural networks, neurons. See, these are nothing but the neurons concept. Okay, so the same neurons that you have studied in biology, the same thing it is. So that is, it is a different study. Okay, we will see later. So you just remember that deep learning is using the neural networks. So it is based on all like this neurons. Okay. Yeah, so neural networks, it is based on the representation learning. Yes, we have seen. Yeah, there are many types of deep learnings. Okay, convolutional means CNNs. Okay, for image and signal processing, for neural networks. Okay, text to speech or speech to text. We have learned. And generative adversarial networking. Okay, if you want to generate new samples. So these are the different types of deep learning. So this and all you are knowing, I think. So game playing, speech recognition. Okay. See, these are all vast techniques. Everything, it's not possible for you to remember, but you have to remember some of the important things. So, machine learning and deep learning, difference between. See, this particular chart I can give you, you can just memorize this. Are you getting?
Okay, ma'am.
Hello. Huh? Because in this, right, you have, there are many questions in this only. Like, suppose you have to define this. Okay, machine learning uses algorithms, deep learning uses neural networks, right? First point. Then machine learning works in small data sets, deep learning works in large data sets. Second point. Third point, machine learning is having what? Manual feature. And deep learning automatically it does the work. Okay, machine learning requires some manual grading, but deep learning automatically it will do. By using the neural networks, automatically it is doing the job. Then next is what machine learning uses simple models. Which are the models? SVM, decision trees. These are the names of the models that we are going to study. Okay. And deep learning uses what? CNN, okay, AGN. All these are the deep learnings. Then this runs on the regular CPUs. And deep learning will not run under our CPUs. It requires more speed, terabytes, gigabytes, right? And machine learning typically is faster for training. Training, it is very faster. Deep learning, if it comes to a trained data set, means it becomes slower. Then machine learning is easy to interpret and understand. Deep learning is very difficult to understand. Okay. And in machine learning examples is spam detection, credit scoring, here, speech to text, image recognition. In machine learning, you are having good accuracy. In deep learning, you are having very much higher accuracy, more than machine learning. And machine learning is less flexible for unstructured data. Okay, unstructured data means what? The data which is infinite. You don't know the limit. There are thousands of rows will be there. There are thousands of columns will be there, right? That is unstructured. You don't know what is the limit, from where it is coming, where it is going. And this is very effective. Deep learning is usually used very best for the unstructured data. So if any image or audios, text or videos you are giving as an input, then also deep learning works very fine. Okay. Hello.
Yes, ma'am.
Okay. So this was about what? Deep learning and machine learning that we studied. Okay, I think so. This much is enough for today, as because it will be too much for you. So next class we'll continue this. Okay, and keep those files with you. As I have shared to you, we will require those files. Right?
Okay, ma'am.
Tell me. Yes.
You are saying that the files you have shared in the last week.
That is now required.
Okay,
Now,
ma'am.
daily it is required, because all combined things, like AI, machine learning, deep learning, everything combined now. We have to learn with a combination of this. Okay. So
Okay.
side by side, once we should be clear with the concepts, then we can start using the tools. Then we can start doing the programs, and then I'll show you how to build a project. Okay, once we have completed this concepts. Are you getting?
Okay, ma'am. Yes, ma'am.
Fine then. Okay, we'll stop for today. Tomorrow we'll continue.
The statistical part is completed, right?
Which one? Statistics. Yes, yes.
Statics. Okay.
Yes, yes. Statistics is completed. Some things, new things will come in our project. That time I will explain you.
Okay, ma'am. In the last class, we have having a issue with the while using the sci-fi while using the stat in the sci while importing the sci-fi when we are using the mean it throw an error like attribute error and
Arithmetic, right?
Yes, ma'am.
Arithmetic mean, I think so, right?
Yes, ma'am.
Huh. Did you do that?
Yeah, I tried, but I didn't get the output yet, ma'am.
Actually, how the code is what you know. You should import your stats module, suppose. Okay, I'll just write the code over here. Let us see. Can you see this?
Yes, ma'am.
Now, we were using what? Arithmetic mean, right? I think so.
Yes, ma'am.
So, simple stats was coming. Or not? Did we do this? Import skypy.stats. Right? Then
No, ma'am. We didn't use sci-fi.stats.
Let's see them. Okay. Then you can give suppose one variable. NumPy means you can take an array method. Right? Hello. We were doing mean, right?
Yes, ma'am.
Mean is a method in stats. So I am giving the mean of A. Then shall I give print? So, okay. Why it is not showing? Error is not there, right? You try?
Yes, ma'am. But I also get that error.
That is not defined, it's telling me. It should not come. It is defined only, right? Yeah, I think so because comma is there. Here. Again, same thing, right? It has no attribute mean.
Yes, ma'am. For the last class, it also showing the error. Like in that class, we have
The
used
same
the
program,
method,
right?
same program with the, uh, we just from sci-fi import stats, we have used that method, but got the same error, like attribute error. Have
Yeah, correct. Mm. It is not taking only me, right? Okay. You have tried any other programs? Any only this one is not working, right? The rest and all is working.
while using the mean, while importing the stat, we got the output. But
No, but mean is not working in any times, huh?
for
Mean is working. Huh? Tell me. No.
we tried some other problems like
Okay.
statistics that mean that and all work.
Let me check. This it SkyPy is not working actually. Statistics is working as we did, right? Statistics part. SkyPy
Statistics
is
part is working. That the
Python
sci-fi,
is
yeah,
not working because
yes,
it is using SkyPy is usually used with multi-dimensional arrays. Are you getting?
okay,
So,
ma'am.
so I am putting x is equal to 0 means 2D array, right? So like that, if I am putting x is equal to 1 means it is an 1D array. So let me see if I put here none because we don't have 2D and multi-dimensional, right? You can just try these programs, this code into your thing because it is coming here for me. Okay. So they have used NumPy. Hmm? Till only this thing you can try in np.array is there, right? Only one line so that it is coming or not. For me, it is coming. Okay.
Okay.
So this are all simple variables they have used mode underscore result, mode underscore value. Don't give this frequency. Frequency is not required for you. Okay. Right now, I'll just comment this. Okay. You can just comment it. See how it works actually here. See the output. Are you getting? Hello. Okay. Data, because I have print the data, right? So it is printing the data, mean, median, mode. And frequency I have given. So frequency it is telling you don't give the frequency. Just print only the output. Now see, right? Okay.
Yes, ma'am. Let me check.
Once you check, give only 3 values and then you can check it.
Okay.
Repetitive, as we were seeing, right? See, 20 is repeated 2 times, 40 is repeated 3 times, 60 is repeated 2 times, right?
Yes, ma'am. Yes, ma'am, got it. Hello.
Yeah, got it, right?
Yes, ma'am.
Okay. So
For using the
initial,
mean and median, just importing the NumPy is enough. For more
huh,
data, we need to
this
use
is
the site.
happening from SkyPy. So see, if I am taking a simple list, suppose I am not using an array over here, then it is difficult for it to calculate, right? How it will calculate mean? Okay, so we are using np dot array, okay, NumPy, and we are putting it in an array so that contiguous memory location will be there, right? And then it is calculating the mean. So 2 times 20, 3 times 40, right? Our whatever concepts we learned, same thing, and you are getting the answer over here. So you don't do for frequencies. Frequency means how many times the count it will show. Okay, if you want, you can do it. Usually mean median mode. Okay, count also we are using in projects. Got
Okay,
it right? From SkyPy import stats.
yes, ma'am.
Okay, so yeah, and any other thing is left? Only this one, right?
Yes, ma'am.
Okay, so yesterday we were doing this AI, right?
Yes, ma'am.
Huh, okay. So once this is over, then I'll show you the tool for machine learning. Do you know Orange tool?
No, ma'am.
Orange, huh?
No.
Oh, okay, okay, I'll show.
Okay.
This is done, right? Deep learning.
Yes, ma'am. From the data, we have to start.
Okay, so deep learning is having three things: neural networks, multiple layers. Okay. Um, what is data, right?
Yes.
Okay. So now data, you know the terminology, raw data you are having, right? So that raw data, you are going to process it. Okay. So once you are processing, you can hear me, right?
Yes, ma'am.
So once you are processing your raw data, then only you will get the information. Okay. So whenever you are having a table like this, which is in rows and columns, so either it can be an SQL table or it can be a data frame. Yes or no? So this table, either you can get it in an Excel, or it can be an database, Oracle or MySQL, or it can be your data frame also. Okay, so each row will be containing an information, right? Now see, each row is having an information. Okay, and here suppose you are having this particular cell. Okay, so for this particular cell, you can, if require, you can put many links for other cells. For example, now in this data table, you are having the fruit names. So all fruit names, you are having the colors over here. So these are nothing but the apple is having a link with this red color, right? So you are maintaining a link for this red color and this dollar price. Okay, so certain features are being fed in this table. So the whole row will be linked in any data. Okay, inside your, whenever you are using any data set with your machine learning algorithms, how does the AI will see the data? The AI will read the whole row data, whole row it will read. So it will make a link now. So Apple is there. Apple, it will try to make a link for this, whether it is there or not. It will make a link for this, whether it is there or not. Getting here. So how does it make a link? Either either by your, you have given some training for it, either you have given some trained data it will use, right? Or it will do its own pattern matching, or it will make some predictions. Okay, anything can be there. So now at present, this is your data. So see here, how does the features comes over here? These are your column names as it is. Okay, so these column names, right? So these column names in your machine learning data set and AI based projects are called as what? Labels. Okay, so see here, these name, fruit, color, price. These are the column names, right? We are calling this as what? Labels. Okay, so it is called as labels, or sometimes it is called as what? Features. One and the same. Are you getting this? So this thing you remember. Okay.
Simply the column names of the table refer as either a
Labels.
label or future.
Labels. Yeah, they will term it as a label. Okay.
Okay.
So label or features, anything. Okay. So here we are having what? Label can be what? Employee name, employee salary, the department name, right? So here the employee, here the column names are what? Here the labels are what? Fruit name, fruit color, price, size of the fruit, right? All these will be the labels for this fruit. Okay, so like that, these column names are called as what? Labels. Okay, now data labeling is the process of attaching any meaning to the data. Okay, so in all the column names that you are giving, that will be having a meaning to all this. So fruit, I am giving a column name. So this fruit column name, it will have be having a meaning to this, yes or no? You just can't give any name. So below fruit, I can't give any other ball, football, and basketball, right? Does it have any meaning in that? No. So whatever column names, whatever label you are giving, that will be having any it will be always having any meaning in that. Okay, so just remember that. Okay, now next thing is what? Suppose in this particular, okay, here the example is of what? Fruits. So in fruits, suppose you want to predict what fruit it is. So you are knowing apple, this is an apple. You are knowing this is an orange, this is a banana, but you want the machine to tell you, right? So how does it tell? How will the AI tell you? So it has to predict, right? It has to first analyze the fruit. It has to predict the fruit, like what fruit it is. So if it wants to give any prediction, so if it wants to give any prediction related to that particular fruit, so what features it will see? For that fruit, it has to analyze some features, right? So suppose apple is there. What is the feature of the apple? It has to analyze whether it is in red color. So suppose you are having two things over here. So here you are having an apple. Okay, and also here you are having an apple, and also here you are having a tomato. So both are red color, right?
Yes, ma'am.
So both features are red color. Getting here. Okay, so both it has to tell, the AI has to tell, the machine has to tell both as what? Apple. But why it will not tell as tomato as an apple? Because of the trained data. Okay, you must, some trained data set is there, so it will analyze that trained data set. It will see already one picture will be there for this apple. You must have, the user will be giving. So according to seeing that picture, it will analyze and it will show that this apple is having a red color. So based on the color of the fruit, so based on the color of the fruit, what is the feature of the fruit, it will give the name, fruit name. So apple is, this is the, this fruit is having a red color, and it will check the train data set. Okay, so this picture matches with this, so it will predict as what, it is an apple. This is how the AI works. Are you getting? Okay, because the machine will not understand, right? Both are in red. Apple is also in red, tomato is also in red. But why it will give this apple picture only? It will show as an apple. Are you getting? Okay, so in this also, in AI and machine learning algorithms, you are having built-in trained data sets are there. All header files are there. Different directories are there. You are going to do what in this? You are going to just call those header files. You are going to just use those methods, those directories you will use. Okay, you will use those trained data, you will use those data sets, whatever data sets is being fed, and you will get the output. Okay, this is what you are going to do. Okay, so practical implementation, you will see how does it works. Now see here, data can be of two types, as we have said. One is labeled and another one is what, unlabeled. So label data means what, where you are tagging it. So here, this is the label data set, right? This is, see here, picture you are see giving apple, this is an orange, this is an banana, right? So this is labeled. But see here, this is unlabeled, only picture is there. Have you given any names over here? Have you tagged anything over here? No. The same thing, the same picture is there, apple, orange, banana, same picture you are using. But have you given any names over here? Tagged, have you tagged anything? No. So what is this called? Unlabeled. Getting here? Okay.
Yes, ma'am.
So this is unlabeled data. So this is your labeled data. Okay, and this is also your label data. Okay, so now this is label data based on what? Based on the color. See, you have tagged these things with based on the color combinations. Okay, so always remember, any unlabeled data will not have any names tagged with that particular image or with that particular picture. Okay, and also it will be a huge amount of data. Unlabeled data will always be an huge amount of data, and it will be in a raw form. It will not be processed, means it will not be having any feature. Okay, any feature, nothing feature is there. It is just as good as you are taking the data set. It can be anything. Okay, so you have to sit and analyze. Now see, this is again same thing. It is a picture of a dog, right? So this is also a picture of a dog. Both are different, right? But both are saying dogs only. Getting it? This is your unlabeled data. Getting here? So see now the difference. Here you have mentioned the sizes. Okay, here you have just mentioned the picture. Okay, so now this is how your AI works, labeled data and unlabeled data. Okay, now same thing, if you go further, this is over. Yeah, see here, trained data set. Okay, now see here how you are going to use your labeled and unlabeled data into your AI model. Okay, so the very first thing what you will do is that you will be having a data set. You have to input a data set. Yes or no? Any model, whenever you want to create. So the very foremost thing, what is required? A data set is required. Hello? Yes? Any model, if you want to
the data.
Acquiring the data, that means what? The collection of the data is there. So data set is required. You will collect the data, right? So once you are collecting the data, you have to analyze it, right? We learned with the AI project lifecycle. Okay. So now what you are going to do is that you will take the input. Okay. So you are taking the input, you are collecting your raw data. Okay. Now, if you are using machine learning, okay, there are many things. You can use machine learning algorithms, you can use deep learning, or you can go with only the machine learning and AI. So if you are using only machine learning, you are taking your data set. Okay. So that data set will be one trained data set. If you are using machine learning, again, I'll repeat, then the data set will be of trained data set. Okay. Already this will be there. Okay. The data set, the examples will be there in that. Now you will acquire, you will extract those data sets and you will just do classification. So you will apply all the classification algorithms of machine learning. So now you are having many types of machine learning algorithms. Okay, that I'll show you how which are the algorithms that you are going to study. So once you are using those machine learning algorithms like random forest, okay, or k square, right? So any algorithms, linear regression, any algorithm you use, so once you are done with the machine learning algorithm, then only it will give you the output. But in deep learning, what happens? The same thing what you are going to do here, you will not the deep learning will not use the trained data set. Okay, it will directly use its own patterns. Getting it? It will check the patterns and it will classify and it was giving you the output. Okay, so suppose for example over here, see here, what do you mean by trained data set and testing data set? So you can see here the testing data set. See, this is your raw data. So whether it is apple or not, you don't know right now. This is an input. Okay, some image you have created, you have done. Now you will put into your machine. So either you will use your machine learning or you will use your deep learning. Okay, so once it is put into your machine learning model, what it will do, it will search for an algorithm for it. So whichever algorithm, suppose random forest is there, any algorithm you check. So it will check this image. So this image size is what? It will check the size of the image. It will check the color of the picture, right? So all those things it will check. Getting here. Once all those things matches with the trained data over in its machine, in its algorithm, then it will give you the output. Okay, so see here the output, it is always giving in what? In your modeled trained data set. Always the output is given in the modeled trained data set. Now, what do you mean by testing data set? Testing data set is nothing but the data which is used to test the accuracy of the model. Now, suppose you are getting this output as an apple, but you don't know whether it is correct or not. You have to test it, right? So how would you test it? How can you test it once the output is coming, whether this is an apple or not? How do you test it? So what you will do, you will match this output with the feature, right? Already the feature is there. So if this output matches with the feature, then it is correct. Okay, so test data means what? You will just test the output. Already the output has come. Okay, that output you will just make a test by using some of the built-in methods, by using some of the built-in algorithms. Okay, now this was only the theory part. All this test data, train data, everything you will be using in your machine learning algorithms. You will be having test data, train data methods. Are you getting? Hello? You are going to use your methods. You will be calling some of the header files for this. Are you getting?
Yes,
Okay.
ma'am.
Test data, train data, this is just a theory part. When you go to, when you see any one program, you will understand. Okay, so you'll be using all different methods. You will be using all different directories. Okay, for each and everything. Now,
Okay,
next
ma'am.
is, yes, AI models. AI models are of two types. Okay, so one model is what? The rule based. So all the AI models, it works only on the protocols, only on the rules. Second one is what? It learns on, it runs on the learning based. So learning based means what? As I said, it is already fed. So some things are already trained to the machine. So if some things which are already fed to the machine means what? It will be machine learning. Okay. So and the second one is what? Deep learning. Deep learning works with the neural networks, as we know. Okay. So now machine learning is having three types: supervised, unsupervised, and reinforcement learning. So all these three types of machine learnings algorithms, okay, these all three models works with all the algorithms. And this also we have seen CNN and ANN. Now we will see in the next part. This is not required for you. This is also not required. This and all right now not required. Yes. Rule based examples. So, which are the rule based examples? Expert system, chatbots, spam filters, okay, tax calculation. And which is the learning based image recognition, chat GPT, voice assistant. So, these examples you have to remember. They will ask in companies interview questions. Are you getting? Which are the rule based algorithm examples and which are the learning based algorithm examples. So, this photo also I'll give you. Okay, so this you have to memorize. This they will ask. Then
Okay.
you are having, whichever is important, right? I'll put in the group. Once it is over, then I'll put in one stroke. So learning based approach. Okay, so this is your categories of machine learning as we have seen. Supervised learning. So supervised learning means what? So suppose you are having in supervised learning, you will be having a particular data set. Okay, so that data set is always be having all the labels. It is always be having the features that we call. Okay, it doesn't have any raw data over that. In supervised learning algorithm, no data set will be having the raw data. All will be having the name tags. So one after the another, all you will be having the tags over it. So suppose, for example, they have written here currency coins. Okay. So for currency coins, okay, so this is 3 grams currency coin. So they are, see here, there are they have given the data set, different currency coins data set having different weights. So already they have given 1 euro weighs 5 grams, 1 dirham weighs 7 grams, all right, $1 weighs 3 grams. So if this picture is coming of 3 grams, so it will check from all these. Are you getting? If this picture is giving me is being given as an input, so this 3 grams coin, it will be checking from these features. Are you getting? So 3 grams comes under where? $1. Hello.
Yes, ma'am.
Okay, so like this it is going to take it. Getting here? So this is your supervised learning. Same thing here also. So these are your cats, something images they are putting, and this is their training, and it is predicting. This is all simple, you can learn. So what do you mean by unsupervised data? Unsupervised data means what? As I have told, all the raw data. Usually these are used for pattern matching. Okay, all trend analysis and pattern matching, it is being used. So now see here, this is the chart. Okay, so in this chart, suppose what you can analyze. Don't go with this. Okay, if simple, this chart is there, 4 circles are there, here 4 and there 4. So what you can analyze by this, these are the groups, right? Clusters. Yes or no? So this is one cluster, this is another cluster. These are two different groups you can analyze. So that means what? If in your model it is maintaining the groups, so you are putting an input over here. So the input is what in terms of your table. Okay, see here, you have put some table, some things, some data, raw data you have put. There are plenty of customer IDs you don't know. There are plenty of grocery items you don't know. Okay, there are number of items sold each and every day. Number of items it is sold. You don't know how many items are being sold. Okay, so you have just like that put everything in unsupervised learning model. And what you want to find out, you want to find out how many of them have shopped, they are doing shopping for grocery, and how many of them are doing shopping for non grocery items. So if you want to differentiate like that, then how you will do that? The same thing, you will go for this particular data is called as what? Unsupervised learning. So here you will be making groups. This is one group, this is the second group. So how does this output come? By using the customers. So it will categorize. Suppose customer ID 1 is there. So customer ID 1 is purchasing, suppose today 5 items. It has purchased 5 items. So it will check, it has to check all the 5 items, whether it comes under the grocery. Suppose a customer is purchasing clothes, means it will categorize it as non-grocery. Getting here? So like that, there are so many customers. Are you getting? So per day, if you will calculate, there will become so many customers. If you go on check per week, there will be so many customers purchasing so many items. Are you getting? So you, if there is no labeled, then you can't do it. Are you getting?
Yes, ma'am.
Hello? Okay, you if you can't differentiate, so for this what you will do, you will prepare the groups, you will prepare the clusters. So this also I'll show you how I'm telling you. Now this is also not done. This differentiation, okay, this you know, right? Supervised algorithm, supervised learning means linear regression, decision trees, SVM. Okay, these are all we will learn. This all we have to go through. Now you remember this, right? Supervised learning means labeled data, and unsupervised learning means unlabeled data. That you are knowing, right? Okay,
Yes,
and
ma'am.
supervised learning means what? Predicting the values, and unsupervised learning means what? Pattern matching. So this you should be clear. Okay, rest and all you can understand when the program comes. Okay. Fine. Next is, yeah, reinforcement learning means what? It works with only the trial and error method. Okay. So how does it work? Suppose you are performing a particular task. Okay. Suppose you are giving a photo of a photo of an apple, a image of an apple. Okay. So how does it work? So it has to be programmed. Okay, so how does that photo of an image? You are not using any of the algorithms, right? In reinforcement learning, you are not using any of these algorithms. See, linear regression, decision trees, K means, hierarchical clustering. All these algorithms, how do they work? They work based on their methods used. Okay, they work based on the header files. You will call some header files, and you will make the output to come. But in this particular reinforcement learning, you are not using any of these algorithms. Okay, so then how does the machine gives you the output? Okay, so whenever you are using reinforcement learning, you are going to get the feedback from the machine. So suppose it is giving you the output. Okay, so the machine, according to the program given, according to the metrics, there are some metrics fed. According to the matrices, what it will give you, it will show you the output. But if you want to see whether the output, whether the photo, whether the image is correct or not, then what you will tell, you will give a negative feedback. Again, it will do the recycling process. Okay, so again it will check. Okay, so explicitly the whole program will work again and again, the same task will be repeated. Getting here? Until and unless you are going to get the correct output. But here in all other algorithms, okay, so in these algorithms, what you are doing, so you are not using those feedback type. Feedback is not there in these algorithms. Directly decision trees is there or linear regression is there means directly you will call those particular algorithm and you will do the program. So this is all very easy. So usually in companies, in all projects, we are using what random forest projects, or we will use linear regression. K-means is very much famous, and hierarchical clustering. So hierarchical K means decision trees, linear regression, and random forest. These are the algorithms that we are using. Okay. So this is just an giving the feedback from the machine whether it is correct or not, and again it will reprocess it. So this is okay. Yeah, see here, supervised learning is again two types, classification and regression. So classification, again, you will be having many examples in this. Let us not go in deep in this. First, I'll show you one program, because simply teaching, it will be boring. Yeah, I have forwarded some of the topics, right? Yeah, you can open the that file that I have forwarded, right? Machine learning.
Yes, ma'am.
Where it is. Yeah, hierarchical clustering, machine learning description, right? So even I'll open. Yes, this is what I have given, right?
Yes, ma'am.
All right. See now, see whatever we you were seeing in the PPT, right? Now correlate with that. What is data? Okay. So data, it can be any raw material, raw data. Okay. Different types of data, input data. It is called as features. Features means what? Labels. Okay. So we have seen. Okay. So now it can be any features. Okay. Feature label can be anything, categorical. Okay. Color, gender. Okay. It can be image, audio, right? And what do you mean by target data? Target data means what? Output data. One and the same, right? Yes or no? So in target data, what you are having? You are having all the numerical value. You can get the categorical value. So output data, is it necessary every time you will get the numerical value only? Yes. Hello.
Sorry, ma'am. Come again.
Output data means what? Target data, which is coming out. So output data, is it necessary every time it should be a numerical value only? No,
No,
right?
ma'am.
Can be categorical also,
Yes.
right? It can be anything. So that only they have mentioned in this. Okay, so these are the different types of data, right? So the types of data in machine learning. Okay, so usually in machine learning, two types of data are there: training data and test data. Now you got, so we were learning this, right? So I'll mark over here: training data and test data. So all machine learning algorithms and models are based on these two things only: trained data and test data. So one is what? It is using trained data, and then you will test it whether the output is given correct or not, whether it is matching or not, because everything is inbuilt. Okay, so everything is already fed into the machines. Are you getting? Hello.
Yes, ma'am.
Okay, so now see, this is a new part, so it will be little confusing for you, or you may not get some things. Okay, it is a common thing, don't worry. So train data, so here you can read this. Now it will be easy for you. So train data consists of what? Input data. So input data means what? Any of its values, any of its features, any of its labels, and corresponding output labels means what? Corresponding output data means what? Target value. Okay, so this is the common thing. Next is what? Purpose. Purpose, usage, and all, you know that. You can read this. Hmm? Yes, test data. Test data means what? It is testing your testing whether whatever result it is coming, whether it is correct or not. So now you have done it. So now we will see the machine learning algorithms. So as said, supervised learning is having two types: regression and classification. Okay, in regression algorithm, you are what you are going to do? You are going to predict a continuous numerical value. So in regression, you will be putting some trained data. Okay, so some trained data you are putting, and you are going to get the result. And that result again you will match with the test data, and you will check whether the output is correct or not. This is only you are going to do in all machine learning algorithms. Are you getting?
Yes,
Hello.
ma'am.
Okay, so this only you are going to do. Now, one program I'll show you. I don't think so whether it is there or not. Maybe this is because all theoretical part, whatever I am taking right now. Okay, one program I'll show you so that it will be easy for you to understand. Wait, uh, data science. Only one program I'll show you, then we will stop. Because if I show you that program, then you will understand actually how it works. I think so. I have given, right? No. Okay, 1 second. Yeah, can you see this? Hello?
Yes, ma'am.
See? See, one program, this is of linear regression. So see how it works. So we are using what? Matplotlib. We are passing the XY coordinates. Okay, we are doing the scatter chart, right? Same program that usually you are using. Now what you are using? SkyPy, right? From import stats, right? Same program. See, once again, I'll show you. So this is your what linear regression algorithm. Okay, we will study what is a linear regression algorithm. So how you are implementing in your Python code, that I am showing you. So see, you are using what? These coordinates, scatter plotter chart. The graph is coming, right? Same thing, you can do it with your SkyPy to draw the line of regression. Okay. So by using SkyPy, what you are using in this, see, linear gress. What is this? This is a method. Hello, are you getting?
Yes, ma'am.
Okay. So inside the SkyPy, this is a method. So what you are doing, you are calling only SkyPy. Sorry, you are calling only linear gress. Okay. Okay, and then you are getting this line with the scatter chart. So plt dot scatter means this dots will come with the linear gress. You are getting this line which is dividing. Okay, so now suppose, okay, now what you can do is that you can see the errors in this. Okay, same chart. If this is what, this is a labeled data. How many datas are there? You are having how many columns? Some 20 columns. You are getting this. But if you are having unlabeled data, infinite data is there. So at that time, what will happen? It can give many results, right? Yes or no? Hello? If you
Yes,
are
ma'am.
having only 20 columns, only 20 records are there, suppose. So the chart will return only 20. Okay, if I'm having only 20 records, so it will return only 20 like this. Okay, dots. But suppose I am having an infinite multiple records. Infinite you are having the data set. So can you give can you consider it as a labeled data? You will consider it as an unlabeled data, right? So you will get what? Multiple linear regression. So in this, see how many dots, how many points are coming? These are infinite, right? So in this situation, more errors it is coming. Yes or no? It is you, when you, as you are having such type of data and when you are getting such types of charts, that time more errors will come. So if more errors will come means what? You have to use train data and test data. Yes or no? Getting here? So now what you will do, whenever you are having such types of situations, you will use the train data and test data into your programs. You have to feed these train data set. You have to call the train data method and you have to call the test data method. These are all the methods inside your program. If you are calling these two methods into your Python code, then you will get the correct form of chart. Are you getting? Okay. Fine. So in this, we are going to now find out the whiskers. Okay. So what is a whisker? It is a box and whisker plot. So all these are similar. Okay. So similar terminology. All these works under the quartiles only. So here see box and whisker plot, you are calculating the whiskers. So minimum value is what? 78 in this and maximum value is what? 120. Okay, so the required 5 number summary will be what? You have to calculate with respect to the minimum and the maximum value. So how do you calculate that? See here 78. Okay, so you will include 78 and 120 in between, which are the possible outcomes it will come. These what outcomes it will show, right? These outcomes are called as what? Whiskers. See now 91 it is showing, but it is not showing 92. Getting here? So why? Tell me why? Because now where is 91 coming? In which quartile the 91 is coming?
Q1.
91. What is 91? 91 is the
Is it the Q1 quartile?
Median, 91
Median
is
of.
okay. So the 91 is the median. Getting it. 102.5 is what? It is the median of the third quartile. See? Okay. And 78, 120 are what? These are the minimum values and maximum values.
Maximum value.
And what is 97?
Oh,
97
these 5 numbers are
median. Yeah. So
Q2.
these 5 numbers are nothing but the whiskers. Are you getting?
Okay. Yes, ma'am.
Okay. See, minimum value, maximum value. Again, I'll repeat. Minimum value, maximum value. Then the first quartile mean that we calculated was 91. Then the median. What median?
Third quartile median.
97, and the third quartile median that we calculated comes up of about 102.5. So these 5 are called as what? Whiskers. Okay, so like this the calculation is being done. Now after this whiskers you are having what? You are going to draw the box. Okay, how do you draw the box? As I told, so from Q1 to Q3 they will draw, then a line inside the box you have to draw, right? So then left whisker and then the right whisker to the maximum. Left whisker always comes with the minimum and right whisker will always comes with the maximum. So in this way the box is drawn. Okay. So this box is drawn means what? The graph is drawn. Getting it? So usually whatever graph comes like this, in terms of like this, not only box it will come, but in terms of these, it is called as what? Quartile graphs or box and whisker plot. Getting here? So you all these comes under this category. Okay. So how do you identify now the outliers? At present here you don't have any outliers because everything is fine. Okay. So if an outlier comes means a deviated point will be coming over here like this, either the left or the right side. Getting here? Hello.
Can you show any examples with the outliers, ma'am? It will be
examples. Yeah, examples we will do the project only, right? In all projects you are having the outliers. We will see that codings will be there, right? Okay. So the codings only, you can see. So right now you can't
do this method. We will write the code to find the outlier also.
Descriptive. What?
Sorry. For identify the outliers, we have to write the code like that.
No, you are just going to call a method. Outlier method will be there. You will call that. That automatically does.
Oh, okay, ma'am.
You no need. You are not going to write any code in from now onwards. You usually write only the logic. You will be writing. Okay, and the concept you are knowing, based on the concept you are building your logic, you are putting the header files, you are using the method, and your code is ready.
Okay, ma'am. There is no need to find the whisker, which is the Q1, Q2, Q3 that are all inbuilt with the code.
Logic you have to remember. I will show you little logic. All the you will be using your methods. Outlier methods will be there. Different methods are there. Whichever method you want, you can use it.
Okay, ma'am. Here we saw 3 methods like set score, a quartile method, and one more.
Usually, so 3 methods you have seen.
Visual inspection. Yes. What we are going to use frequently?
In your projects, right? Apart from
yes,
based on this, you are asking, right? So see, yes, usually, right, Z score and all. They are depends. They are not usually using that much. IQR only we are using more. Okay, as an statistics part. And if it comes to in this quartile, and if it comes to distance based means K nearest we are using. Okay, so this only I am going to explain now. These methods, right? This is all one line, right? K nearest neighbors. So this is what it is identifying the outliers. And how it is identifying outliers, it is having one algorithm. So that algorithm you have to study. So K nearest neighbors, okay, K is a constant value. That K value you are going to give. And you are going to call that K nearest neighbors algorithm. Okay, and it will do automatically its job. So usually you are using IQR in all projects, K nearest neighbors algorithm you are using, cluster based methods you are using, hierarchical cluster you are using. Okay, so these are the common
Okay.
and mostly used. Okay, all these clusters, hierarchical. So now I am going to explain that only. Are you getting? So these are
Okay,
all
ma'am. Yes,
different
ma'am.
forms, okay, of identifying the outliers. There are so many. Everything you can't remember, and everything is not necessary to go because it's not used. So
Is there any particular way, or can we use any kind of methods for identifying outliers, or else for certain data sets we have to use this method
certain,
like that?
in certain according to the certain projects, okay, there are, as I told, a trained data set is there. So as the trained data set, what outliers they're using, the same outlier you have to use. So according to the data set,
Okay.
your outliers you will use, and according to the project, okay, what they are suggesting. So that usually, right, you are using clustering, okay, hierarchical clustering, okay, all these usual methods, okay. So
Okay, ma'am.
hierarchical cluster, yeah, SVM. Just now you are seeing right, support vector machine. So SVM, K nearest, clustering, all these are the commonly used, okay, which
Okay, ma'am.
identifies the outliers, okay, in different ways, okay.
Yes, ma'am.
So how does these outliers are identified? So mainly remember KNN, K nearest neighbors, then what is that? Support vector machines, okay, hierarchical clustering, right? So these three you should be perfect, right? So
Okay,
now
ma'am.
same thing. I will explain the same thing. I thought it is finished. So these are the types of algorithms, okay, that fit into your machine learning model, and you can use in your AI also. So what is the type of output that you are getting? Suppose the output you are getting as discrete classes, then it will be termed as what? Supervised and classification. If the output is continuous, means you will be termed as what? Regression and supervised. So based on the output, the algorithm they have already predefined. Are you getting? Hello.
Yes, ma'am.
Okay, so this is the training data set. So how do you predict the incoming inputs? So these are all output. If similar group of output is coming, means you will use clustering algorithm, unsupervised. You will go. So this chart you have to memorize because this is a trained data set. This is like this only it will come. Getting here. So if suppose,
Ma'am, correct me if I'm wrong. If the
hmm,
training dataset has output like discrete classes, then we have to use the algorithm classifications
yes, very
like
correct.
that. Okay,
Yes,
okay, ma'am.
category of algorithm is classification supervised. It is fixed. So
Okay.
there is
Based
no
on the
chance.
training
Yes,
dataset, we have to decide which algorithm we are going to use.
yes. So here you are going to input your train data to into your model. You are fitting into your model, okay, which is going to predict incoming. So this is the usual used, okay.
Okay, ma'am.
So you will not go for discrete classes there. You will not go for clustering because clustering means what? Grouping. So that doesn't match
Yes.
also. Right, clustering means what? Grouping similar things you are grouping means clustering. So you will not go. Discrete means it is different. Continuous means continuous. So 3.141111 data is there, right? That is continuous. Whenever recurring value is coming, so 3.14111111 like that it is coming means what? It is continuous. The output is continuous means what? Regression will be there. Are you getting?
Okay, ma'am.
Okay,
Yes, ma'am.
so this is used. Now, if we come under classification, right? So as we said, classification means what? It is given labeled input data. Okay, so as you remember, right? You are having labeled input data. Okay, so in this, see, you are classifying. See how many data sets are there? There are n number of data sets, but you are classifying it by according to its labels. So this is one particular label column. This is another label. This is another label. Are you getting? So based
Yes,
on
ma'am.
all these label attributes, you are doing your you are determining your insights. Okay, so usually classification algorithm is there. So it is huge. It is based on your machine learning techniques. Okay, so now suppose for example, if I tell which example I can tell for you. Um, yeah, whenever you are having any predefined classes, right? So all the predefined classes you are using, right? Suppose for
Like the
example,
example you already said, spam detection like that.
yes, spam detection methods. So that is all medical diagnosis, right? So all these are nothing but the classification algorithms. Okay, so means what? These are used only for the specific categories. These are used only for the specific classes. Okay, so it is an algorithm which is designed for showing only the specific categories or for showing only the specific classes. Okay, so usually what you are going to predict here you are going to predict all your new data points, whichever new data points are being coming. Okay, so these classification algorithm will use what data set, as I have mentioned over here, labeled data set. It uses what? Labeled training data set. So again I'll repeat, classification algorithm uses labeled trained data set. Okay, and in this classification algorithm, each data, okay, each data will be associated with a particular class. Okay. Hello.
Trained data sets.
Yeah, it is using labeled
Okay.
trained data set. Trained or not,
Okay.
supervised, it comes under what? Supervised machine learning algorithm. It is a technique of supervised machine
Labeled
learning.
one.
Okay, so just remember two things. First one is what? A classification algorithm comes under supervised machine learning technique. Okay, it is a part of supervised machine learning technique. Second thing what you will remember is what? It is used to classify. Classify means what? Categorize. Yes or no?
Yes, ma'am.
Classify means what? Categorize. So it is used to categorize your data into different categories. Okay, you can make your data into different classes, or you can make your data into different categories. Now a simple example, for example, you can say that animals are there, right? So you can classify it into different categories, right? So you can make it as classification of dogs, right? You can have the classification of deers, which are vegetarians, right? So you can have different animals categories like herbivorous, carnivorous, right? Or else if you are having a classification of your, if you are having a vehicles, right? So you can classify it how uh, three-wheel vehicle, two-wheeler vehicle, and four-wheeler vehicle. Yes or no?
Yes.
Right, two-wheeler, three-wheeler, four-wheeler. And again you can have the classification as what? Petrol based vehicle, diesel based vehicle. See, these are all real time, you have to think over. There are many examples will come across. Then you can also classify as what? A light weighted vehicle, heavy weighted vehicle. Getting here?
Yes, ma'am.
Okay, so this is what your classification. So it uses what? Labeled data. So your label is there, right? So as I showed a dog picture and I told, I have put a label that this is a dog. I have trained my model, my machine learning model like that. So it will give me any time as a name called as dog only. Same thing, if I put a truck over there and I will put it as a heavy load vehicle, means it will show always as an heavy load vehicle. Getting here? So only in classification algorithm, what we tell, it uses what type of data? It uses the trained data. Okay.
Yes, ma'am.
Okay. So only we are telling trained data. Trained data means what? Already been fed. Okay.
Yeah.
Yeah. So next is what? A regression algorithm. So what do you mean by regression algorithm? So whenever you are having any continuous values,
Numerical values. Yes. Okay.
Okay. So continuous values, you are having what? Regression algorithm. So regression algorithm is also what? It is a part of a supervised learning algorithm. Okay. So
Yes, ma'am.
whenever you are predicting any continuous form of output, you want to predict any continuous form of output, you will have the regression algorithms. So as you can see the chart, right? So what is this? You are having the regression algorithm. Now this is a curve. So these are what? These are the data points. And this is the curve, right? So regression curve is there. Instead of regression curve, we can put a line over here. So that will be called as what? Line of regression. Yes or no? So either you can have what? A curve. So this is called as what? Hyperbola or parabola, whatever it is. Okay. So this is the curve. So I can call it as a parabola. If in place of a curve, if one line is there over here, which is differentiating my data points, right? So if I'm putting a line means what? It is a regression line. Okay. So both are possible over here. Okay. You can get your output anyways. So this is one of the output. So here you can see this is the true value, blue color. Okay. This is the true value. You have given it, right? And red one is what? The estimated value. Yes or no? Getting here?
Yes, ma'am.
See, these are all, as I said, these are all trained inbuilt predictions. So the chart, whatever, whichever project you do, program you do, it will come like this, more or less. Getting here?
Yes, ma'am.
Okay. So this algorithm, what it is doing, it is predicting your output. Based on an input values, it will predict your output values in terms of continuous dependent values. Okay. So all continuous dependent values will be coming as shown over here. Okay. So as I said, you can have linear regression. So linear regression means what? A line is there. Okay, whenever a line comes, it is called as linear regression. And whenever you are having a regression by having any curve, then you can call it as what? Any modeling growth curves like this. Okay, this is called as what? Modeling growth curves. So usually when this is used, whenever you are calculating your population surveys, right? Okay, population trends. There are many data points. Yes or no? The population is so much. So can you use the exact value over here? If a population survey is there? Hello?
No, ma'am.
Right? So in whenever you want to predict any population trends, at that time you will have these curves like this, regression curve. This is called as what? Polynomial regression. Okay. And if you are getting a line, that is called as what? Linear regression.
Linear.
If in place of a curve, if a line is coming means it is called as what? Linear regression. Okay. So
Okay, if it is a
usually,
curve, it is a polynomial.
polynomial. Yes.
Okay.
Okay. Yeah. So next is what? Clustering. Yes. Hello.
Yes, ma'am.
Hello.
Yes, ma'am.
Hello. So clustering algorithm. So this clustering algorithm, as you can see, there are different groups, right? Now clustering
It's
algorithm,
unsupervised.
unsupervised, very correct. It is an unsupervised machine learning algorithms. These groups are called as what? Clusters. Okay. All these groups that you are getting, right? These are called as what? Clusters. Okay. So now as it is an unsupervised, so obviously it will not use label data set. Yes or no? Hello.
No, it's unlabeled one.
Unsupervised means what? Label data set, label data it
Unlabeled.
will not use. Unlabeled it will use by default. Okay. So you don't have any predefined, any groupings are there, predefined any categories will be there. Nothing is there in this. Okay. So usually clustering, there are many types. Okay. But we are using, there are so many types, but usually we will go with the hierarchical clustering. Okay. So in this hierarchical clustering, as I have will show you, I think so. Down it will be. No, it's not here. Okay. It's not here. Hierarchical clustering, a different file is there, I think so. Leave. I'll just tell. It is not there. So, what do you mean by hierarchical clustering? So, it is a type of an unsupervised machine learning algorithms, and here, as you don't have any predefined labels or predefined values, the only thing is that hierarchical means what? Tree shape. Okay, you will be having. Okay, you will be having the visuals in a tree shape, and this hierarchical clustering, okay, the result will come in an hierarchy which is called as what? The visuals will is called as what? Dendrogram. Hello, are you
Can
there?
you repeat it once again, ma'am? That means
Again, I'll tell. See, types of clustering are many. So we are learning only hierarchical clustering. Hierarchical clustering is an unsupervised machine learning algorithms. Okay. So in this, you are having n number of groups. Means what? N number of clusters are possible over here. So here you don't have any predefined labels or predefined groups or predefined values. Okay. You are not going to have any of the labeled data set. All unlabeled are there. In this you are having the output, okay, that you get. Okay, so you will be having a tree shape, tree like diagram will be coming in hierarchical
okay,
clustering.
the output will be like
Okay,
a tree
and
like.
the output that you are getting as, yes, it is called as what? Dendrogram. The output
Okay,
results in
ma'am.
an hierarchy. See, the output results in an hierarchy. Okay, hierarchy means what? Like a tree format. Okay, so this output is usually it is in the form of a hierarchy, but actual hierarchy will not be there, to be frank. Okay, when you see, it doesn't seem like a tree structure. That output visual hierarchy is called as what? Dendrogram. So you are they will tell you dendrogram graphs nowadays very usually they are using. So what do you mean by dendrogram graphs? These are nothing but the hierarchical clustering. Means the base value is there. From the base value, from the super values, the sub values will be there. So usually, why it is used? These are used for the smaller data sets. Whenever you are having a smaller data sets and you want to find out the relationship in between the two data points, getting it? So whenever a pattern you want to find out, or whenever a relationship you want to find out, then you are going to use clustering. So basically, you are having one more thing that is called as k-means we are using. So this is used for smaller one, and k-means will be used for larger data set, like that. Getting here?
K mean also a type of clustering or
It
it's
is
a
also a type
different.
of clustering. Yes, it is also a type
Okay.
of clustering. The difference is what? This is used for smaller, and because it is a smaller used is for a smaller data set. The clusters that appear, they are not that much clear. But in K means it is used for by a larger data set. So the clusters that they form, right, that they give as an output, they are very much clear in that.
Okay. Clustering means based on the similarities, we are grouping them, grouping the data set. Like, is it correct?
Yes,
Okay.
grouping the data set means means what you are telling. I am not getting. Grouping
Based on the
means
similarities, like it's an unlabeled one. Based on the similarities
uh,
between those data
un,
set.
unlabeled only, but in a tree format.
Okay. Okay, ma'am.
Okay, so based on the similarities, you are grouping together, but you will be having different branches. Like trees are having different branches, right? So you will be
Yes, ma'am.
having different branches over here. So I don't have a diagram over here. I think so. I will just tell you. See, I'll just put a photocopy of this because I don't want to draw it right now. Dendrogram. It is called as what? It is named as dendrogram.
Okay, ma'am.
Okay, I'll show you later. I'll put a photo of
Okay,
that.
ma'am.
Okay. So next is what? Um, Which one is the next? Did you get the photo that I have drawn? Just I have put one photo of a dendrogram.
In the group.
Yeah, in the group only I have put. There is one file. I'll just, I don't know where I have kept. And the messages are not going, I think so. Now you check, it's coming, huh? 23rd June only, right? Your batch.
Yes, ma'am. Now.
See, two images I don't know. See, A, B, C, D, E, F, G, H. So these are all branches. This is called as a dendrogram. Okay?
Okay, ma'am.
Hierarchical clustering form. So now what is a model? This and all you know, right? What is a model, an AI model, and who has invented it? This person has invented it. Okay, that is all not required for us. So dimensions and features we know. So whenever you are having, right, you are having projects. So at that time, you should know these things. Features we learned, right? What is a feature in a data set? Okay. So any feature, it means what characteristic, which is describing your column. That is called as a feature. We just now, that day I shown, right, in AI PPT. Feature,
yes,
labeled, unlabeled feature, right? So instance is what? Any single data point, okay? That is, instance. And what is a dimension? The attributes, one or more attributes, okay? So whenever you want to calculate, okay, when you start a project, you should know what is the shape of your data set. So whether your data set can be a CSV file or your data set can be a data frame that you are doing, anything it can be, right? Your data set. So always remember you have to import, okay, your load underscore digits. This is a method by which you can know your target. What is the target? What is the data? So all these things you should know. You should do in your projects. So here in your load underscore digits, you are importing this particular header file, right? So this comes under what? sklearn. So I have taught, right, sklearn the header file.
No, ma'am.
No. So sklearn means what? Skykit. I have taught, right? No. sklearn, skykit, I have not taught. So sklearn means what? Skykit learn, a header file. It is a free and open source machine learning library. Okay. So skykit means what? sklearn, both are same. It is a free and open source machine learning library which is used for only Python programming language. Okay. So why it is used? All different types of machine learning algorithms are over here only. So which are the machine learning algorithms? Your just now we seen, right? K nearest neighbors, regressions, linear regression, okay, clustering. K means clustering, then classifications, support vector machines. All these algorithms come under the sklearn. So if you want to use any machine learning algorithms, it means you have to call this sklearn. Okay. And if you want to do any aggregations with respect to your data set, means you have to call like this: from sklearn.datasets, import load underscore digits. So load underscore digit will, what it will do? It will calculate the shape. Now you know, right? What is the shape in your data frame? Yes.